Hello, today it is going to be 2x2 system. I'm going to approach this system of equations hopefully comprehensively. I'm going to deal with some multiple different approaches to solving this. First and foremost, we will deal with a graphing technique. When you're graphing a system of equations, you are looking to see where they cross. So, taking a look at this, we can come in here, I can get a coordinate plane set up. Okay, I'll first start with my maroon. I have a y-intercept of 0, 1, and a negative slope of 2, so up 2 over 1, 2, 1. When you're graphing, you want to make sure to get as many points onto this coordinate plane as possible. That will maximize your chances of seeing where they actually cross each other. Great, there we go. Now I will start with this line. I have a y-intercept of 0, 7, 2, 4, 6, 7. And I have a slope of positive 1. And there it is. I can see it. Down 1 over 1, down 1 over 1. That should get us there. And if I had a straight edge, it would look a lot nicer. I don't have one handy. Sorry about that, but we can get darn close because we have so many points. There's one. My second line. Is right there. Now, where do they cross? Negative 2, 1, 2, 3, 4, 5, negative 2, 5. That is the solution to this system of equations. It is the point that when plugged in here, it will make it true, and when plugged in here, it will make it true. Okay, let's keep going now. Slide it up, make a little bit more room. Let's go y equals and y equals. Give us a little break. Okay, y equals, first of all, negative 2x plus 1, and y equals x plus 7. Okay, I've used two different colors. Unfortunately, I didn't choose different ones because they're kind of close together. Y equals in red, and then our equations in our other color are maroon. This is called substitution. Both of these equations are equal to y. Both of these equations are equal to the same thing, which is y. Since they're both equal to the same thing, you are able to come through and set them equal to each other. Now we eliminated a y variable. All we have left is x, so we can go right ahead and solve. If I subtract x, negative 3x plus 1 equals 7 minus 1. Negative 3x equals 6. Divide by negative 3. X equals negative 2. We're going to take this and you are going to plug it in to one of these two original equations. Doesn't matter which. You get to choose. Hopefully you pick the easier one. I will pick this second equation here. Y equals x plus 7. And x happens to be a value of negative 2. So when we clean that up, we end up with y equals 5. Solution, negative 2, 5. This point will satisfy both of these equations. That is the exact same point as we reached up top when we graphed them. They are the same equation, so they should have the same solution. All right, there we go. 2 x in pink, and then x equals y minus 7. looks a little bit different, but just to let you know, all this system of equations, the one that we're dealing with, and I do say one, it is the same system, it is just in different forms. So depending on the form, one approach may be a little bit easier than another. This is also called a substitution. Now, I know what x is. X is y minus 7. So if I were to take this x value that I see here, which is y minus 7, I can take that whole thing and I can put it in place of x. So when I do that, here's what it looks like. 2x plus y equals 1. That's my original equation with a set of parentheses where my x is, to leave room to substitute. And what I am substituting in here to this place is a y minus 7 value. What comes in? Y minus 7. Now once we clean it up, we have no more x and we should get an answer. Distribute 2y minus 14 plus y equals 1. 3y minus 14 equals 1. Add 14 to both sides. 3y equals 15. Divide by 3. Y equals 5. You take that and you sub it back in to either one of your previous equations. It doesn't matter which, whichever is easiest for you, hopefully. So x equals y minus 7, and in this case, y happens to be 5. X equals negative 2. Solution, negative 2, 5. Same thing that we have reached with our previous 3 techniques. We will do one more. Now, we will use what is referred to as elimination. So let's start with 6x plus 3y equals 3, and x minus y equals negative 7. Our system of equations. So let's solve it now. I'm looking at these. The goal with elimination is to add our two equations together. Take the green and the red, add them together with the hopes of eliminating one variable. So for instance, if this is a 6x right here, when we added them together to get the x's to cancel, this would need to be a negative 6x. If this is 3y, this would need to have a coefficient of negative 3y. So you get the option to really make this happen however you see fit. I'm going to choose to eliminate the y's. If that is 3y, that will need to be a negative 3y to make this happen. So the green doesn't need to change. 6x plus 3y equals 3. The red, on the other hand, x minus y equals negative 7. This red equation, to make my y's cancel, would need to get multiplied by 3. So now, what I really end up with, 6x plus 3y equals 3, and my new modified red equation, 3x minus 3y equals negative 21. Now when we add these two equations together, let's see what happens. 9x, my y's cancel, which is our intent, equals negative 18. Divide by 9, x equals negative 2. Take it, once again, plug it in to one of our original equations. You get to choose the very best one, and you are not it. You get to pick. Make it easy on yourself, please. I'll choose red. X minus y equals negative 7. In this case, x is negative 2. Negative 2 minus y equals negative 7. If I add 2 to both sides, I get negative y equals negative 5. Y equals 5. Solution, negative 2, 5. Same thing that we reached previously. They are all the same system in a different form.